Hello. Hi. How are you doing? Welcome back to the channel. This is AD from Silverlight Studio, and today in our How to Java series, we will be picking up from where we left last time. If you remember, then we went over how to actually download and install Java, and then we wrote a very simple program called Hello World, which just basically prints Hello World out when we run this over here. So that's what we did last time. Today, we're gonna move ahead and we're gonna write another program which includes more lines of code than this basically uh, 2 lines, not even 2 lines. This is a method. This program just had 1 line. We will write today a program which includes more code. What's the program? Well, today we will be making a calculator in Java, and we will run it. And this calculator is supposed to take in 2 integer values and return their sum, their difference, multiply them, divide them. So a calculator which can add, subtract, multiply, and divide 2 numbers is the goal for today's video. So I'm going to go ahead and close what we wrote last time, and we will begin with our calculator. So let's begin. First things first, as always, we will open it with a class, and let's name it calculator because that's what we are doing. So we go ahead and name it calculator, and we're going to save it as the name of the class. If you remember, the name of the class and the name of the file should be the same. Otherwise, we will get an error saying it could not locate class or something like that. So calculator is the name, and the type is a Java source file, which just means .java at the end. So go ahead and save that. We are saving in this folder again, and let's go ahead and save that calculator.java, and that's the same as what we have here. Calculator, same as what is the name of the class is the same as the name of the file. Great. So now we can begin. As always, I'm gonna write the main method first of all, and the main method is always public static void main. Well, not always, but for now it's this string arguments. This is the main method. So we go ahead and keep our main method here. We don't need it right now, but we will just write it and of course open it, close it, and between these brackets will be the code for our main method. So we have made a class, we have a main method, and now we need to fill this up with our code for our calculator. We will need a few things. I will explain them as I write them. First of all, we need 2 numbers to actually add, subtract, multiply, or divide. So I'm gonna declare 2 variables named A and B. So these 2 variables are what's gonna be subtracted, added, multiplied, or divided. So we're gonna do A plus B, A minus B, or B minus A, depending on which is greater, and A times B, or A divided by B, or B divided by A. That's how we're gonna do it. So integer, this int small means integer, and this means that the variable A is from type integer, so it can only save integer values like -7, -1, 3, 5, 10, 12, but it cannot save decimal values like let's say 3.72, and that's double value. Java doesn't consider that as an integer, and neither is it an integer. And for that, we have something called double or float. If you want to write decimal values, we cannot use integers. We need to use something like double or float to represent them. But for our purpose, for our calculator, we just need to input numbers in form of integers. So we're going to keep it as int small. And what I'm doing here is I'm initializing them to 0. This is called initialization. You can also just keep it like this, int a, it's fine. But it's always good practice to initialize your variables with some value. So I've set a to 0, I've set b to 0. That means at the very, very beginning, both a and b are 0. And we can add or do whatever with them. If you don't initialize them, they have some, let's say, some garbage value, which gets overwritten when you run your program. But it's good practice to always initialize them like I've done here. So to input integers, now we also need something to store the result. And for that, I'm going to make another variable called res. Res is meant to, I'll write in comments, meant to store the output. The screen text, what you see is comments. They help you understand the code, but are themselves not a part of the code. So you write 2 forward slashes. That means you're writing comment. I'll do it again. 1, 2 forward slashes means that you're writing comments, which again can be used to describe the code, but are themselves not a part of the code. So now that we have our variable set up, we can start working. And the first thing we're going to make is a way to add two numbers. So we will write public int sum int a int b. This is the method which will allow us to add two numbers. Public, so that it is accessible from anywhere. Right now it doesn't make a difference, but in later videos we will go over packages, what packages are. And when it comes to that, then we have to be careful what we write here. Public, private, protected. But for now, public is fine. Integer. This integer does not mean this integer. This integer means the type of data that we're going to be getting back. So we add two integer numbers, a plus b, or do a minus b, we will get an integer back. So we tell to the Java compiler that this method, which takes in two integer values as input parameters, gives us back also an integer value, which is this thing, which is this thing here. So it tells the Java compiler we're going to be getting an integer value back. Sum is the name of this method actually. Public, again, public means it's public. Integer means we're going to be getting the name. The output of this method is going to be in the type of integer, and sum is the name of this method. So if you want to call this method, we have to use this exact name, which is sum. So what does sum do? Sum adds two numbers and gives us the result back. So we will do result a plus b, and we will do return result. And we go ahead and close this. Very, very simple. We take in the third variable, which is result, and result is equal to the sum of a and b. And in the next line, we return return means end this method and give back this value. That's what return does. So return, as soon as the Java compiler sees return, it ends the method and gives us res, or the result, back. So now we have that. Let us go and test it if everything is working before we move ahead with our program. So I'll keep it here. So we wrote our sum method. We have nothing in our main method, but that's okay. We just want to test if everything is fine here, or we made some small errors. How do we test it? Well, we just compile. And if you remember it from the first video, any errors that you make in the program, when you go to compile that program, it will tell you, Java will tell you, hey, we could not compile your program because of this and this and this error. So what I'm going to do is I'm going to navigate to the folder where this is saved, which is this one here. And to navigate to it, I'm going to write cd followed by the name of the folder, which is SOSE underscore 25. There we go. And now to actually list the files that are in this folder, I'm just going to call dir or write dir, which tells me the files that are in this folder. You can do it on any folder. For example, I wrote dir when I was inside my C drive. So it told me everything that I have inside my C drive. So hello was what we wrote last time. It's still there. But our new program is calculator. So we will go ahead and try to compile calculator. Let's see what happens. Oh, we did make an error. I forgot a semicolon at the end. Every statement except method declarations, except class declarations have to end with a semicolon at the end, which is basically what it's telling me over here. So now I added the semicolon. Let's try and compile it again. Great, it compiled. So we are fine. Our program is working fine till now. So we have a method, a way to add two numbers. We also want to add a method to subtract two numbers again. We will write public int because the difference of two integers is always an integer. So we'll write int a, int b, and we will open this, and like we did for our sum, we will use the res variable, which is this here, to store the result of a minus b or b minus a. But before we do that, I will add an if statement. If a is bigger than b, then we want a minus b. In other cases, we will do b minus a. So we go, if a is greater than b, then res is a minus b. If a is not bigger than b, then we just want to, or if it's equal to b, then we just want to do b minus a. Minus a. There we go. And we will go ahead and close this, and we will return the result like this. So now we have a method which can subtract two integers. Like the sum method, we are using two input variables, a and b. But in the case of the difference or the subtraction, we are actually checking if one of them is greater than the other. If A is greater than B, then we do A minus B. Otherwise, we will just do B minus A. These if and else statements are used to control that. If A is greater than B, then do what's here, what's inside the if statement, inside the brackets of this if statement. If A is not greater than B or is equal to B, then do this, which is inside this else statement. This is known as if else statement. If true, then do this. Otherwise, do this. And after checking what's greater and what's smaller, we're not actually checking what's smaller, but whatever. If after checking what's greater than, which one of these values is greater, and doing the minus operation, we return our variable, which is res. So now we have a method which can subtract two integers. So let's go ahead and test that again. Perfect. It works. Not works, but it compiles without any errors. That means we have not made any errors in our program. Not syntax error. There might be runtime errors. When you compile a Java program, it just goes through the code and basically makes sense of that, or better said, it generates a class file which you actually run when you run the Java program. For example, we wrote hello world last time. We compiled that and we got a hello.class file. And when we run, then we run this class file, which basically contains the machine code which your computer understands. So that's what we did last time. And similarly, here we ran the compilation on our calculator file. And since the compilation was successful, we have made a class file, which is this one here. So everything seems fine. Now before we move on to multiplication and subtraction, I'm going to show you how to take input from the user. You notice A and B are 0. And if we just do sum, if we just call sum here, then it will always be 0, because 0 plus 0 is 0, 0 minus 0 is 0, but we don't want that. We want the input to be coming from the user or the person who's using our calculator. To do that, we need to take in input from this command line interface. How do we do that? We do it with something called scanner. Well, there are multiple methods to do it, but for now, we are just going to use scanner because it's pretty beginner friendly. So we write import. Import, as the name suggests, imports, but here imports a class. If you were to write import hello, then it would import the code which is inside hello.java, and we would be able to use it inside our calculator program. So it's like an extension. You can think of it as an extension, or better think of it as importing the tools that you need to run your current program, because we need scanner to take in the input. We wrote import java.util.scanner. This is defined. This is already present in Java. You don't need to, you won't find it on your, well, you can find it on your computer, but that's not the point. The point is that java.util is a library. And from this library, we are going to import the scanner class, which is, let's say, built in Java. You don't need to write it or download it. It's when you install Java, it's there. And if you want to use it, you just write import java.util.scanner. Okay, so now we're going to use this scanner to take in inputs from the user. So let's actually tell the user first that he or she needs to enter something for the program to work. So we go system.out.println, and if you remember from the last video, all that this does is prints something out when we run this program. So we'll go enter the first number. So we wrote our print statement, and we'll just run it shortly to see if it's okay. So we compile our program again, and it will give us a class file, and we run that class file to actually run our code. So we go Java calculator, and you see it prints out enter the first number, which is inside our main. The rest of the code is being compiled, but since we are not using it, it doesn't make any difference in our output. So now we are actually going to use scanner to take in inputs from the user. This is the syntax for scanner. You write scanner, SC1. Scanner is the name, is the type, is a type. And we declare SC1 as being an object of set type. So SC1 is an object of type scanner. And we initialize it with this variable new, which means that SC1 is a new object of type scanner. And what does SC1 do? Well, notice here it says system.out, here it says system.n. So what SC1 does is it takes in what we write here. So if we write 3 here, then SC1 will read 3 as an input. So that's the function of the scanner. Scanner is the type, and SC1 is an object of such a set type, and it just takes in the next input. So we need some place to save this input. So let's declare another variable. Let's say it's D, or let's make it C. SC1 dot next int. So we declared another variable of type integer. So C is of type integer. And what does C do? C stores the input which we get through scanner. So we do scanner, we initialize the scanner, and now since our scanner is initialized, it can read inputs which we give out here. But we need some place to save those inputs, so we do integer C, telling the Java compiler that C is of type integer, and C stores the input which we read with the help of our scanner. SC1 is the name for our scanner again, and dot next integer, which is the long form of this big int, just tells C to save the next integer which we write here. So if we write 3 here, then it would be read with the help of the scanner, and integer C will save that 3 in itself. So C will come 3. So now that we entered our first number, we're going to go ahead and do the same for our second number as well. System.out.println, enter second number. And we will use another variable to store the next number. Same as we did here with C, we'll use D to save the next number that we write after our first number, and that will be saved inside D. So now that we have our input set up with help of scanner, and we have our integer values C and D saving what we input, we can actually start calling our method. To store the output, we can use any variable. We can use this again, or we can define another variable. Let's go ahead and do that. Let's define another variable, int out. So int out. Int out will be used to save the output of our addition and subtraction operations. So it's different from res. Not to get confused. When we call this method sum, it takes into values and it needs some place to save those values. The result is just a place where we can save the result of our addition or our subtraction, and we give result back. In our main method, we can use any other variable to store the output. The res, we don't have to use res again. So res does not mean that always the output is going to be inside res. So we will write, we don't need to declare it again. Since we wrote integer out here, we can just simply write out is equal to sum C and D. This line will call the method, which is sum, and notice sum has to have input parameters. These things is called, these things, or right now this thing is called an input parameter. What are those? These are the values which we give to the method when calling it. So when we call sum, then it expects us to give it two integer values, like integer a, integer b. In our case, we're going to pass it the integer values c and d. So we will write out, which is a variable of type integer, and we're going to write out is equal to sum of c and d. Sum is the method, and c and d are two integer values that sum will use, and it will add them up and return the result inside this variable. So now that we have actually done adding, we need a way to print it out. So we will use system.out.print ln again, and we will just print, let's write the result, let's write addition result and let's make it so that we print our output, which is out, in the next line. If you were just to write print, you can also just write print. What it does is that it prints in the same line. So if we have entered the first number and then we, instead of doing println, we do print, then it will print, enter the second number in the same line. And we don't want that. So just keep ln. ln moves it to the next line. So enter the first number in the next line will be enter the second number instead of both of them being together over here. So enter the second number, or enter second number. I forgot to add that. Enter the second number. So now that we've written a decent amount of code, let's go ahead and save our file. And let's go ahead and try to compile it. Let's see if we made any errors. Oh, we did. And this error, which says non-static variable out cannot be referenced from a static context, means that this method is, the main method is static in nature, but out is a non-static variable since we declared it here inside our class, which notice it says public class. It doesn't say public static class or public static sum or public static int sub, which means all these methods are instance methods. What are instance methods? Instance methods are methods which work on an object, which basically means that we have to create a new object of type calculator, be able to use these instance methods. You will see what I mean when I just change our code a little. We're going to create a new object. Let's name it cal. And this is how you create an object. All these static methods, all these instance methods like public int sum, public int sub need an object to work on. You cannot just call them like this. They need to be called on an object of the same type. Of the same type, I mean, since we're making a calculator, we need to create an object, cal, of type calculator. Cal is a calculator, and cal has all these things. And since we have created an object named cal of type calculator, we can use it inside our code, and it will not give us this error. So let's start with the first error. So we wrote out is equal to the sum of C and D. If you go back to sum, you can see it's an instance method, meaning it needs an object to work on. So we're going to go ahead and add the object which is named cal, and we'll do cal sum C and D. And I think we have another error inside out. True. So we'll do cal dot out. So now that we have created the object, let's save that and let's try running our code or compiling our code again. It seems we have still one error remaining. We are calling it on cal. This error that we're getting right now, out is equal to cal.sum cnd. It has nothing to do with our statement. It has to do with this thing here. We declared out as a non-static variable, which is basically this thing. And we are using it on an object called calculator, and we're doing the sum on it. Since Java wants this variable to be static, so we will just take it out of the class, and we will save it inside our static method, which is the main method, public static void main. Static means it's static, as the name says. For some reason I did not copy it, but we will just write it. Int out is equal to 0. Now this is let's say it's a method level variable, and since it is inside a static method. This means that we should not get this error. It's a static variable now. Let's go ahead and compile it again. This error was because out is already defined as cal.sum, and we took out out of our class. This means that we can no longer do cal.out because cal is an object of type calculator, which means cal is this thing, everything. When you compile or run your Java program and the compiler reaches this line, it creates a new calculator named cal, which has all these things. And since we took out of the class, it's no longer valid. So there is no out in our calculator, which is named cal. And that's what we were trying to do. So it gave us an error. I think it says pretty well here, variable cal out of type calculator, which basically means in cal, there is no out. Okay. Since out is now a method level variable, we can just go ahead and print it normally. And let's go ahead and compile that. There we go. This means that our code is now fine. We had a few errors, and now it should be working. So we did the sum of two numbers. Let's also do the subtraction. For that we also need a variable to store the result. Let's just name it out2. Initialize it to 0, and out2 is like out a static variable, which means we should not get this error again. So going to go to out2. You can use out again, but I think it's more beginner friendly when you make it like this. You define variables, what they do, like this. Out2 stores the result of subtraction, and out is a method level variable and stores the result when we add two numbers. So we'll do out2. And what is out2? Out2 is the sub, or the difference, of C and D. We will just scroll back to our method to see if it's correct. Public int sub integer a. Well, I'm going to make this a bit bigger for now. We don't really need the command prompt. So we have out, which is a method level variable, and it's being used to save the sum of two integers, C and D. So out is equal to cal.sum. It goes to sum. Instead of A, it passes on C, and instead of B, it passes on C, adds them up, and this result, which is given back to us, is stored inside out. Out2 does the same with sub. It gives in two inputs, C and D, which are of type integer, so it passes, and then it executes the code, checks if one is bigger. If not, then do this, returns the result, which is saved in out2. So we'll just go ahead and do system dot out dot println, and we will just print out out2 like that. There we go. So now let's compile this file again, and let's see what happens. So we call the compiler. We made another error. We forgot to add our object that we created, cal, and since out our sub is a non-static method, it requires an object to work on, which is cal. So let's go ahead and save that. Let's run the compiler again, and it compiles. Since it compiled, let's run the program. Let's see if our calculator can do anything. So let's do 5 plus 5, see what happens. So we got the addition result 10, and we got the subtraction result, should be 0 as it is. But it doesn't look that good. To just make it look a bit nicer, we will copy this, paste it here, and just say subtraction result. Subtraction, oh, not a subtraction, 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 or you can just write minus. You can write whatever you want inside these println statements. It never makes a difference for now. Okay. Since we changed our program, every time you change a program, you should compile it, save it, then compile it, just to make sure that you haven't made any errors. So we go java c calculator.java to compile this file, and then we will call or run our class file. So we will do 5 plus 5 again. We'll enter 5, we enter the second number, which is 5, and we get addition 10, subtraction is 0. Let's actually try to make a use of our if block. So we are passing 5 as our first integer, which is here c, and here it's a, but when we write 5, then c is being used to store it, and we pass c to sub, I believe it's c, yeah. We pass c, so instead of integer a, it's getting c, and instead of integer b, it's getting d. If a is bigger than b, then do a minus b, otherwise do b minus a. So let's test it out with a few values. So let's do 3, and let's do 4. Addition is 7, and subtraction is -1. Since, well, let's run it once more, then I think it would be better. Let's enter 4 first, and let's enter 3. Addition result is 7, subtraction is 1. So what's happening when we are passing 4, 3 and 4 to sub is instead of integer a, it gets 3, and of integer b, it gets 4. It checks if 3 is bigger than 4, which is not the case. So it goes to this else. Else does 4 minus 3 and gives us 1. And in the next step, we entered the first number as 4, which is integer a, and the second number was integer b. We checked if 4 was bigger than 3, which is indeed true, and then we returned the result as 4 minus 3, which is 1. So we get here 1, and here also 1. It doesn't go to -1 because we check which one is bigger, and then we do the minus operation. Again, we used, I'm just going to make this bigger. I think we are done over here. Our calculator works fine. I wanted to also do multiplication and division, but I think this video is getting too long. We will handle that in the next part. I will just shortly go over what we wrote today. So just go ahead and exit that, and let's make this bigger. So things to note: java.scanner. If you want to take any input from user, use scanner. You need to import it with this statement. This is built in. You don't have to write it or download it. This is built in. we will come in later videos, we will come to files that we create ourselves and then import it in other programs. But for now, we will use what's built in into Java, which is scanner. So we go ahead and import that, start our class, define some class level variables, and then we wrote our methods, public int. This int means the return type of this method is of type integer, which indeed it is. Result is the sum of two integers, which is always going to be integer, so we write integer. Same for sub, the difference of two integers is always an integer, so we just write public int sub, which means the return type is of type integer. Coming to our main method, we defined two variables here as well, out and out2. Out is used to store the addition result of C and D, and out2 is used to store the subtraction result of C and D. Then we created a new object because public sum and public int sum and public int sub are non-static methods, or they are instance methods, so they need they need an object to work on. If we wrote something like public static int, then it's a static method and you can use it normally without having to create an object. But in our case, since they are instance methods, we need to create an object, which we did with our cal. We created a new object named cal of type calculator, and then we used a scanner to take an input, store our input, and we then printed it out. There are println statements and using our two out variables. So that was calculator. As I said, I actually wanted to make also multiplication and division methods, but I think this is going to take a long time. And this video is already long enough. I hope you learned something from this video. And if you have suggestions to improve on how I can improve, or any other questions or any other suggestions, be sure to leave them down in the comments. And in the next part, we will go over this calculator again, but we will try to expand it a little so that it can also do multiplication and division. We might see some new things when it comes to multiplication division. It's not well, it's simple, but it's not as simple as plus and minus. Let's say it that way. So that was all for today. This was AD from Silverlight Studio. Thanks for watching. Have a nice day. Until next time.